Assalamualaikum students. Students, in today's lecture, we are going to cover topic KPC, right? You know what is partitioning? What is partition coefficient? Partition coefficient actually shows that how a solute distributes itself between two immiscible solvents. Like, look. There are two solvents that are immiscible in a container. They're not going to mix, and you add a solute. That solute will distribute itself between the two solvents. So the solute now is dissolved in both the solvents. In one, it would be definitely more, in the other, less. The solute distributes itself between two solvents. Right? And they become an equilibrium is reached. And we apply the equilibrium law. Right? So KPC is partitioning, distribution of a solute. So we take the ratio, because it is an equilibrium. KPC is the ratio of the concentration of a solute. You can see on the screen. It is the ratio of the concentration of a solute into immiscible solvents in equilibrium. I'm going to explain this with the same on the same PDF, and I will use both, okay? The notes as well as I'm going to explain it, okay? So if I explain KPC, what we are supposed to do is, suppose this is a container in which there is this one solvent. Suppose it is 100 centimeter cube water. And this contains 5 grams of X. And now, what you did? You added octane. You added what? Octane, which is also liquid, and it is 60 centimeter cube. And octane and water are what? Immiscible. They don't dissolve into each other. And after adding octane to water containing this, we are going to mix and shake it vigorously. Like you are going to shake it vigorously. When you will shake it vigorously, the X in water will come in contact of octane. You take water containing X, you want to transfer X from water to octane, but they're not mixing. This is just interface. Very small particles can go around this up and down, not too much. So we need to mix it vigorously. When you will mix it vigorously, then what you're supposed to do, look, I have written all this in the notes. That suppose this is what? 100 centimeter cube water containing 5 grams of X. This is petrol or octane, 60 centimeter cube. They're not going to mix. So we are going to shake it vigorously. So water and petrol are immiscible. To transfer X from aqueous into petrol, the whole mixture is vigorously shaken so that X come in contact of petrol. After mixing, the mixture is left for some time to reach equilibrium. During this time, the X will distribute itself between water and petrol depending on the solubility. The X will be more in the layer in which it is more soluble. So, this is your X in water, and this is X that is transferred into petrol. If you after mixing, you will keep it for some time so that they reach equilibrium. Like, look, after mixing, leave them to reach equilibrium. For example, for example, for example, initially it was 5. How much transferred? 4. Out of 5, when 4 transferred, how much is left? 1. So how I will write this in equation form. Initially, 5 was in 100. Then out of 5, 4 is transferred. How much left? 1. Now, what is Kpc? X in petrol divided by X in water. The X distributes itself between two immiscible solvents. X in petrol divided by X in water. This is concentration. So how you will define Kpc? Kpc is what? Ratio. Like, KSP is what? Product, not ratio. But Kpc is what? Ratio. Ratio of what? Ratio of concentration. Kpc is ratio of concentration of a solute between two immiscible solvents. A ratio of concentration of a single solute into immiscible solvent. Now, you see that the value is 6.7, which is more than 1. More than 1 means the numerator is more. Means that the solute is more soluble in the solvent that you are keeping in numerator. If Kpc is large, more than 1, large, if the solvent in which the solute dissolve more is kept in the numerator, but if you keep that solvent in the denominator, it would be what? 1 by Kpc. Look, this is the definition. Sorry. Ratio of the concentration of the solute between two immiscible solvent. X distribute itself between two different solvent. Right? This is the whole explanation. After vigorous shaking, if it is not left to reach equilibrium and sufficient time is not given, then equilibrium will not be reached. Then all the calculation would be incorrect. Right? Now, this is a question from May, June 2024, 4-1. Right? I think in the previous papers, since 2000, since when Kpc is there in the course, it's very long, right? But in the previous paper, I think there are only 2-mark scheme in which they've given 2 answers for the Kpc. Like, suppose, if I keep this over this, my value is 6.7. But if I keep this in the numerator and this in denominator, my answer would be what? 1 by Kpc. And that's 100% correct. So only in 2 past papers, in the mark scheme, both the answer are given and they are like accepted as correct. And it's actually the case, like both are correct always. But most of the time, we find only 1 in the mark scheme. And when we find 1 in the mark scheme, we think that this is the only possibility, which is not the case. Both are correct. And one, the solvent with the numerator is more soluble, is kept in the numerator, and in the other it is kept in the denominator. So coming to this question, look, what are they saying? They are saying that 80 centimeter cube of aqueous solution contain this much of propanoic acid is shaken with benzene. See? This much propanoic acid in water is shaken with 100 centimeter cube of benzene. Now one thing, be careful. Is there a hydrocarbon chain? Yes, this is also hydrocarbon, more soluble. This is understood. A hydrocarbon is always more soluble in the hydrocarbon containing solvent. It was how much? 0.704 in 80. So when they are shaken 0.556 propanoic is in 100 of the hexane. The remaining is in water. Calculate the Kpc. So what I'm doing, 0.704 in 80 is in water. Then what happened? Then benzene is added. In benzene, how much is transferred? This much. So how much is left? 0.704 minus this. So this much is left. This much is transferred. So if I keep it here and this down, I get answer 3.01. And if I put this in the numerator, this in the denominator, I get this. Both are correct, but in past papers, I'm going to change this previous. When I'm writing in past. But in past papers, they just give one answer, and you people think that that is just one possibility, which is not the case. Which is not the case. Now, see, in June 2024, they've clearly given the mark scheme that both answers are correct. Right? Now, next, when you will do questions in the past papers, topicals, keep in mind that if Kpc is more than 1, this shows that the solvent in which the solute is more soluble is kept in the numerator. Right? Like we know hydrocarbon are always more soluble in the hydrocarbon. So if Kpc is more than 1 and you know the solubilities, you're supposed to keep that in the numerator. And the reverse is the case for this. I'm going to explain this point, right? Wait a minute. Secondly, like what? I'm repeating. You have to keep that solvent in the numerator in which it is more soluble, in which the solute is more soluble if Kpc is more than 1. And secondly, in previous questions, the aqueous, the water solvent, in most of the questions, like in past papers, like I'm actually saying in the past paper question, the water is in most cases in the denominator. Like in previous papers, when you will do topical, the water is mostly kept in the denominator. And this is not the case always. Read and think about the solubilities before proceeding. Look, water and octane 1 are 2 layers. They are immiscible. Ethanamide is more soluble in water. See, they are giving you this in the question. It's more soluble in water. Since it is given in the question, I will keep aqueous layer in the numerator. And I will get exactly the same answers as given in the mark scheme. I will get exactly the same answer given in mark scheme, but if I put in denominator, still it is correct, although not given in the mark scheme. Do you get my point? I think it is summer 2025. It's not summer 2024. Yes, I'm making this. It is 25, sorry. Look, both are correct. But what will help you more? If they give you that it is more soluble, keep water in numerator. You will get the answer that is given in the mark scheme. For example, see, ethanamide in water, ethanamide is more soluble in water than octane 1. When 1 gram of ethanamide is added to 50 of the water, 1 gram of ethanamide is in 50 of the water, and this is then shaken with 50 of the octane 1. It is found that the aqueous water layer contains this much. What this shows? Ethanamide in water was 1 in 50. And after adding octane 1 it's 0.9. So 1 minus point is Look, out of 1, if this much is left, 1 minus this, how much is transferred this much? Huh? So, 0.935 or 50 divided by 0.065 or 50. You will get what? 14.3, and this is your marks scheme answer. But one thing, if you put this in the numerator, this is still correct, but would not be given in the marks scheme. Still correct. Be confident. Your whole question would be correct. Don't worry. Now what are they saying? 50 of the water containing how much? The remaining? 50 of the water containing the remaining is then shaken with 100 of octanol. How much transferred? Look, it was 935. If x transferred, how much is left? Minus x. Now, in this whole situation, under the same condition means temperature not changed. The temperature is kept same. When the temperature is same, the Kpc is same. Like we know it was 0.935, x transferred minus x left in 50, and we know that Kpc is this much. So what am I supposed to do? 0.935 minus x. Now keep in mind, this 14.3 is when the water is the numerator. So you have to keep the water now in the numerator. Divided by x over 100. Find the value of x. Now, another question. Kpc for benzoic acid in octane 1 in water is this much. Repeat. Kpc for this between octane 1 and water is this. Is this less or more than 1? More than 1. If this is more than 1, you are bound to put the solvent that is in which the solute is more soluble. How you will know that it is more soluble? Can you see hydrocarbon and hydrocarbon? They are both more soluble. You have to keep the octane 1 in the numerator and the water layer in the denominator. So 0.4 gram of benzoic in 25 of octane 1-ol. How much? 0.4 in 25 is shaken with what? 125. Out of 0.4, how much is transferred? X. How much is left? 0.4 minus x. Huh? If x transferred, minus x left. Now your next step, which one is in the numerator? The one in which the solute is more soluble, which is octane. So you have to put 0.4 minus x over 25 numerator, and this one is the denominator x. The Kpc of benzophenone between octane 1-ol and water is different from the Kpc of benzoic acid. Look, benzoic acid with this and this, and now benzophenone with this, with octane 1-ol and alcohol. Which one is more solid? Look. You're supposed to do this type of comparison. This is C-octane 1-ol, water. This is C6H5COOH. I agree that is more soluble, and the Kpc is 79 something. Now there is another solute, benzophenone. Which one would be more soluble in octane 1-ol? Definitely this. If it is much more soluble, the Kpc would be much more large. So what you are supposed to write? Benzophenone, more soluble in octane 1-ol due to more hydrocarbon chains than benzoic. Therefore, Kpc of benzophenone in octane 1-ol in water is larger than that for benzoic acid. Like its Kpc between the two is small, and its Kpc between the two is what? Large. I hope you understand. You're supposed to do the practice of all these questions from the past papers, from the topical. You will find my topical on my website, Chemistry by Zeenat. And now don't forget to like and subscribe my channel. See you in the next lecture. Okay, Allah Hafiz.